Okay, class, we're going to continue our discussion of energy, the U.S. and energy sources, part 2. In this part, we're going to focus more on alternative and renewable sources of energy.
I hope we covered things that are less sooty.
Well, yes, we'll get to things that are less sooty in this section. So, among the alternative or renewable energy sources, we have hydroelectric energy, such as the Hoover Dam. We have wind energy, or windmills, and you can see to the bottom right a picture of a set of windmills, but also notice the size compared to sailing boats. Solar energy, which can be either through voltaic cells or passive thermal energy. Geothermal energy, capturing underground heat. And biomass or biofuels. Now, of course, one type of biomass would be burning wood, but we're talking about, in addition, other types of biomass, such as producing ethanol from corn. And there are other ideas of how to grow plants, particularly to produce ethanol or some fuel molecule. Now, we're covering these things very, very quickly because in many cases, we'll talk more about a particular type of energy source in subsequent chapters. The purpose of this lecture is to give a very top-level view. Now, how are these uses of renewable energy sources changing with time? This is shown in this slide. These are estimates from the Energy Information Administration, a federal government agency. And this shows conventional hydroelectric power from dams has been pretty much steady and is projected to be pretty steady in the future because there are only so many places that these hydroelectric dams can be built. The most significant increase for a non-renewable energy source is that of wind. And you can see that it's projected that in the near future we will be producing as much or more electricity from wind power as from hydroelectric. There is also projected increase in solar and geothermal and some in biomass. So that whereas only about 10% of our current energy sources comes from hydroelectric and other renewables, the projection is that this will increase in the future. And the advantages of these renewable energy sources are, first of all, that they are renewable, and secondly, that by comparison to fossil fuels, they're much less polluting. Let's also talk about nuclear energy, which has both problems and opportunities. In the United States, we obtain about 8% of our electricity from nuclear energy sources, but in some other countries, a much higher percentage of electricity is obtained from nuclear energy. In France, for example, 77% of their electricity is produced by nuclear power plants. Nuclear is an attractive source of energy because it produces such large amounts of energy. The source, uranium and other ores that contain radioactive materials, while limited and non-renewable, that is, once they're used up, they're used up, the estimates are that there are significant reserves of these radioactive materials. The problems, of course, are the need to store the radioactive waste because the waste products produced by nuclear power plants are radioactive. And that means that they can cause damage to biological systems, including us. There are other safety concerns with respect to meltdowns of the plants and release of radioactive materials into the environment. The three most noted examples of this were 3 Mile Island in 1979, Chernobyl in 1986, and the tsunami off the coast of Japan that caused damage to the Fukushima nuclear power plant in 2011. Now, of these, the Chernobyl accident meltdown was by far the most significant compared to the other two. Now, we may discuss these in class, in a lesson, because these are examples in which there was much more panic and concern in the public than there were actual fatalities associated with the accidents. But in fact, when you say nuclear and nuclear power plants, this is a cause of panic in individuals. So one of the issues here is how do you convince the public to balance the level of concern with the opportunity to produce energy. I also write down fusion. Fusion is a type of nuclear reaction which could lead to the production of energy. It's actually the type of nuclear reaction that takes place on the sun. And nuclear fusion reactions are much less polluting than are nuclear fission reactions, the type that we now use. The problem is that the technology to develop a nuclear fusion power plant always seems to be in the future. That is, research is still being done, and nuclear fusion reactors are not yet at the point where we can use them for generating electricity. In the next course, and I hate to keep always saying this, but in the next course we will have a complete chapter on nuclear science and talk much more about nuclear power and nuclear fission and nuclear fusion reactions. Now, in addition to producing electricity, we also have to transmit this electricity from the sites at which it's produced, the power plants, to the sites where it is used, that is our homes. How does this happen? Well, it turns out there is a national electric grid. In fact, in the United States, there are three major parts of this grid called interconnections. There's the Western interconnection, the Eastern interconnections, which you can see is most of the country, and then also the Texas interconnection. Those people from Texas always have to do their own thing. And what this means is that at any point in the Eastern interconnection, the grid is connected to other parts of that region. And so you may hear stories about a brownout or a blackout in one part of the eastern United States, and how our power plant in the state of New York, for example, might affect people in Cleveland, Ohio, because all of this is interconnected and the electricity is shared from one place to another. Now, for the most part, of course, the electricity is used nearby where it is produced, but the grid is interconnected so that the electricity can be shared from one part of the country to another part of the country. Now, while it makes sense to share electricity, that also means that this electric grid has to operate efficiently. The simple transmission of electricity down these wires results in a loss of energy due to friction of the electricity moving through the wire, the resistance of the wire. It's estimated that between 6 to 8% of the electricity that is generated is lost in the transmission process. Not a high percentage, but still there is some loss of energy just due to the transmission process. Some of the concerns are that the electric grid in the United States is an aging grid using wires and cables that are getting old, that could be more efficient, have lower resistance, leading to less loss of electricity, and that we need to upgrade and replace some of this grid. And you may also hear the use of the term smart grid. That is the use of technology to more efficiently manage the transmission of electricity from places where it is needed to places where it is not needed so much at that particular time of day or that particular location. That is switching the transmission of the electricity in a more intelligent way. Another topic with respect to the electric grid is that some of these alternative sources, including hydroelectric and solar and wind, are likely to be generated far from where the electricity is actually needed. The most effective places to produce solar and wind energy would be in the Midwest, far from the populated areas, so that we would have to transmit that electricity even further, leading to loss of that electricity in the transmission process. So I just wanted to point out some of these factors related to the transmission of electricity and how this is an issue as well as our ability to generate electricity. Now, moving on to transportation. We use petroleum primarily for transportation in the United States, gasoline and diesel. And some recent advances in technology have included more efficient automobiles, what are called the CAFE standards. CAFE stands for Corporate Average Fuel Economy Standards, and how the federal government has set these goals or standards for miles per gallon for automobiles, and the automobile producers are working towards meeting these standards. We are also seeing the development of electric cars, the Chevy Volt, the Nissan Leaf, which involve powerful rechargeable batteries. A question with respect to electric cars is that the batteries are an intermediate way to store the energy, but the energy has to come from some power plant, so that this would indirectly put demand on fossil fuel resources. So it's not that using an electric car would move away from fossil fuel energy sources necessarily. Now, of course, the electricity could be generated by hydroelectric or wind or solar. If the latter were the case, we would be putting less demand on fossil fuels. Hybrid cars. I'd like to have a hybrid car. Maybe I will buy one sometime, but it combines the use of gasoline-powered motor with an electric motor, so that the battery for the electric motor is being recharged while driving, including while decelerating. The Toyota Prius is an example of a hybrid car. You may also hear about fuel cell cars. These are cars that would use hydrogen as a fuel, hydrogen along with oxygen as a fuel. The interest in fuel cell cars is that the hydrogen and oxygen, when reacting together, would form water. That is, water would be the waste product, which, we don't think of water as being a pollutant. In a sense, this would be much better, but the problem is that there are safety issues with respect to handling hydrogen gas. It's very explosive, and also at this point it's still very costly. And we don't have an infrastructure for distributing hydrogen gas. That is, if you go to the filling station, they don't have a pump for hydrogen gas for you to connect to. The two most recent cars that I bought had, something like 36, 38 miles per gallon. It is interesting to look at a global perspective. If you've ever been to Europe or Japan, you'll know that their cars tend to be much smaller, but they also get a much higher miles per gallon. That is, they're more fuel efficient. Looking at the plot and looking at the most recent dates, you'll see that in Japan and in Europe, the average automobiles get 45 miles per gallon or above. Whereas in the United States, Australia, Mexico, the average new car gets maybe 33 or so miles per gallon. So in fact, cars are being made that are more fuel efficient. They just tend to be smaller, as you can see in the illustration on the left, compared to what we're familiar with in the United States. The CAFE standard projections do require an increase in the miles per gallon or the fuel efficiency of automobiles made in the United States in out years, which will be achieved both by having more efficient engines, also perhaps the use of more lightweight materials in the construction of the vehicle. Okay, we'll pause now. We've come to the end of our set of video lectures on energy and society. We've given you this top-level view of the energy landscape in both the United States and from a global perspective. We've seen that some of these energy resources, particularly fossil fuels, are non-renewable, whereas we've said that other sources of energy are renewable, including wind and solar. Now you may wonder, how does this relate to that first law of thermodynamics, which says that energy can be neither created nor destroyed? How can we have renewable energy? Well, actually, planet Earth is an open system. Remember when we talked about open, closed, and isolated systems, and we said that the first law applies for isolated systems? Planet Earth is really an open system. That is, energy is constantly impinging upon planet Earth from radiation from the sun. And thank goodness it does.
So, you are going to keep sticking it to me.
Well, electrical outlet, I suppose it's true. We're still going to depend upon you. Electrical outlets are extremely convenient. Just think about it. Energy can be released from some source, such as burning coal or natural gas, or a nuclear reaction. That can occur hundreds of miles from our home, and then the energy comes whipping down the wires, almost at the speed of light, and is delivered right to our homes in these little wall electrical outlets. How convenient is that? So yes, we have become quite dependent upon electricity and electrical outlets.
And next it will be cars. Cars. Can you believe it?
Well, and yes, maybe even for cars. In one of our next lectures, we'll learn more about electromagnetism. But before that, we're going to cover the second law of thermodynamics, the all-important, always present, always dominant second law of thermodynamics. See you then. Beep cars.